All right. Hello. So, this week's live stream is going to be kind of back to a bit of a pattern we had for a little while before the holidays, which is mostly working on Incus OS and a bunch of the supporting components. I'm going to start with just a bit of a recap of where we are with this thing right now. There was a mention, I think, on Twitter maybe, asking, hey, like, how do I actually install this thing? What files do I get? How do I install this on a machine? Currently, the answer is you don't. It's still actively being developed. We're still at a stage where all of the development is done through virtual machines running on Incus. So that's kind of the main way this has been used so far. But a bunch of things kind of fell into place over the past few months. So basically, all of the image building logic is now currently in place. So effectively building one main image, which is the operating system image itself. It's based on Debian testing. It's designed to be quite lightweight. Can actually go look at one of the most recent releases, the build from yesterday. And that should give us an idea for the size. So yeah, 287 megs for the whole thing. So that's pretty lightweight, and that's the just checking something here. Yeah, so that's the main image itself. So that's Debian with systemd, with some of the support components, file systems, whatever in place, as a UEFI image to run on systems with like modern x86 systems with EFI, secure boot, and TPMs. And then on top of that base image, we've got two application packages or system extensions, as they're called, that can be deployed on top of that. So there's one that's called debug, which includes just some debugging tools. I believe we've got strace, netstat, ps, a few other tools in there. And then Incus itself, which includes Incus and most of its dependencies, which is quite a large application to deploy on top of it for 185 megs. So that's kind of the base structure. So every time the image builds, it builds the base and then the two extra applications. And after that, the focus, so that effectively all works. And there's a bunch of kind of tooling also around it that's been built to test it. So we effectively have two scripts these days. There's one script that can be used to grab a particular release and deploy it on Incus as a VM. And it also currently directly applies the two applications, so debug and Incus, and gets it effectively operational to a point where you can interact with Incus. But it only works as a VM like that. And then we've got a separate script which is used to trigger a OS update. So effectively downloading the update files for the new image and pushing those into the existing VM and triggering an OS update from inside the VM. One nice thing with the way Incus OS is structured is that it's designed for A/B type updates. So when you do that, it effectively writes the update to the B side of the OS and then triggers the update, which reboots onto that B side. And if something goes wrong, it can revert back to the A side, and then the A side is used for OS plus atomic type update system that's in place there. So then the next step is, okay, well, that's all nice and well, but this is all running inside of an Incus VM. That's not really what we want in practice for production deployment, obviously. So to get us to actually being able to do production deployments, what we need is have a way to provision this thing so that if it's deployed on a random Intel NUC laptop or server or anything, on first boot, it should know how to initialize itself, mostly things like adding trusted certificates for someone to connect to it, bringing up the network, bringing up storage, and also doing the actual updating and managing the applications. So that's what I've been working on and off here. I've actually pushed just a few minutes ago what I have on my system. And that's that work on the Incus OSD, which is a piece of Go It's currently a standalone kind of one-time command, which is going to turn into an actual daemon. Just haven't done the daemon part yet. We can actually go look at what it does currently, and then going to be working a bit on expanding that. So currently what it does is it initializes the, actually, let me see if I can make that a bit bigger, Firefox. Initializes a logger, then it goes and pulls the kernel signing keys. The reason it does that is to check whether our own signing key is in there, to check whether this is an official release build on a system that's got secure boot enabled. And that's used to effectively determine what the runtime mode is. So if we don't find anything, we assume it's unsafe. If we find our own key, we assume it's an actual proper release image. And if we find a make OSI of something key, we assume it's a dev build, because that's what you get if you just run make in the repo. You're gonna get one of those. And then we can just move on. Like, we'll also show all of the keys that are found on the system as we process them. And lastly, at the end, we effectively show the starting up and in what mode. There's also currently a hard-coded application of Incus here. That's because we normally expect that we're going to be running Incus on top of this thing, but that's not always going to be true. Some of the work we're doing on the Future Fusion side, we're building Operation Center and Migration Manager as extra components for larger scale Incus deployments. And we want to use the same Incus OS base for those systems. So in this case, we're going to effectively have something in the configuration that's going to tell us, okay, this system is starting up, but it's not starting up to run Incus, it's starting up to run Migration Manager or to run Operation Center. And at that point, we'll know what application we are supposed to be running. And in the next step, where we actually connect, in this case, to GitHub to go look at OS extensions or system extensions, we'll be able to go and look for the one we actually want. So currently, it's effectively hard-coded in here that we pull the debug.ra and incus.ra. So we pull the debug and incus layers, and then we apply them. But that part would actually vary based on the application. And I think it's also like we're going to have a flag to effectively say, hey, this machine is supposed to run with debugging, in which case it will pull the debug layer, otherwise it won't. Anyway, on startup, it effectively downloads the extensions, puts them in place, and then it does a couple of calls to systemd to actually apply the extensions, create any users that needs to be created following the extensions having been applied, and then start the services. So that's basically where we are. Now, I actually have a build that's currently ongoing, so I can show an update, but I saw it wasn't quite running yet, so let me check what's going on. Okay, all good. So it shows, I was just looking at the GitHub Actions. So that's the commit I pushed, and then I pushed a release as well just a few minutes ago. We can see that it succeeded. So that means we now have a new release here as of 5 minutes ago, which includes the new files. So with that in place, I can actually show you what it looks like to currently deploy this thing on top of Incus. So we need to look at the release list, and we're gonna on purpose download like an older one. So that's one from yesterday. And then we're gonna be able to trigger an update on that. So I'm on my system here with a git clone of the branch. I'm just gonna go and delete my current test VM here. So test Incus OS can go away. Okay. And actually have a slightly modified version of the script, which actually skips a bunch of stuff. So I mentioned earlier that currently the spawn image script also downloads the layers and applies them. I've got all of that commented out. I could actually go as far as removing that logic because I'm getting close to the point where I can push that to the main branch. So I can remove that logic and just only grab the image and just call it done once the image has started, and not try to apply any of the system extensions. And we'll do the same thing for when we apply an update. So when applying an update, it's currently, what's it doing exactly here? Apply. It applies the update, but again, it pushes the extension, which we don't need to do. So we can remove those bits for sure. That triggers the update, that reboots, but we shouldn't be doing any of that. And in the download part, we're probably gonna want to also skip anything that's not an update file. I just need to figure out what the right rule is for that, because the update files look like this. So we probably want it to start with Incus OS and skip anything else, basically. That should do it. Okay. Could probably do a grep directly in this guy. That'd probably be fine. So that should then skip the ones we don't want. Oops. Come on. Yeah. Okay. So anyway, time for a quick demo of what that looks like. So it's effectively the current logic we have minus the part that it won't do anything with the system extensions, because the work I'm doing right now is on the logic to apply those. So we don't need the scripts to work around that. So do spawn image, that takes the version we want, which is the one from yesterday, and then the name of the VM, so test Incus OS. And let's go. So that's downloading the main image itself. Then it will do the repacking to turn it into something that Incus can run. As in, it will just turn it into a QCARTO image and then import it into Incus. Okay, there we go. It's imported, and now we're creating a VM from that. And what happens now is that when the VM starts, it's gonna do the initial secure boot registration. So we should see that shortly. I thought that spawn was actually showing. Oh no, spawn doesn't show it. Never mind. It's when you run make test that you see it happen. Spawn doesn't. Spawn just has it happen in the background. So what's actually happening in the background is there's a first boot of the VM, which then loads the secure boot keys in place. Then the VM reboots and boots the actual OS. And once the OS is actually booted and responding, then we're gonna get, well, this command is gonna exit and we'll be able to actually talk to the VM. Okay, there we go. So we can see Incus OS, that release is now running. And if we go in, we're in the VM and there's no Incus or anything. It's just the VM is running. So, and if we look at, I think it's OS release, should show us that. Yeah. We can see the version we're running. So image version is 2025 0114 2355. Now let's update that to the image that was built just a few minutes ago. So we can run, in this case, update image. And then again, the version we want, so it's gonna be this one. And then the name of the VM, so it's test Incus OS. And that's downloading some of the artifacts for the updates to different partitions. And just pushing that into the VM and then triggering the update. There we go. So what we see here is actually the output from system, the OS update logic. So up here we can see it. We pushed those files into the VM, and then it shows our current image is here, so 0114. The new image it sees is here, 0116, and it then detected the different block devices where it should write the new update. It wrote the update in place, and then was instructed to go ahead and reboot. So in this case, we actually see that the status right before reboot was current, well, actually that's right post reboot, which now shows that we're on 0116, come on 0116, and we've got 0114 on the other slot that's installed and kept around for now until the next update, and then the next update would replace that slot and reboot. So that's effectively the update mechanism. It's currently driven externally through that script. That's going to also move into the new command and daemon. But for now, we can actually see that the update mechanism works properly. Now, let's look at that new command. So in the Incus OS folder, we can actually go and build ourselves. So I build it statically. We can go and build ourselves a new version of the binary. There we go. And then I'm gonna get a shell inside the VM, and we can transfer the Incus OSD binary into the VM itself. There we go. And then run the binary. So we can see it. It starts with looking at the trusted system keys. It sees that secure boot platform key for Incus OS 2024. So that's the production release key that's loaded. So therefore that shows that starting up, we're in release mode. Then it went to look at GitHub and found that the latest version of Incus OS is 2025-0116. And then went on to download the two system extensions, refresh system extension on system, refresh the user list, started the units. Which means at this point, we've got Incus. We can initialize it, and we can start containers and VMs, and that will all just work. Right, so one container, one VM on just a quickly initialized Incus, that should all be fine. Here we go. So the VM is still starting up. The agent is not responding yet, but the container is fine. And here we go. I think the VM is, yep, the VM is up and running now too. So that's all working as expected, but obviously there's a bunch more work needed on the daemon, which is, first of all, currently not a daemon. It's just a random Go command tool, which is gonna turn into a daemon over the next few days, most likely. But yeah, there's a bit more logic to add in there. So there are, I mean, out of the things to do, one of them is, well, there's a bunch more things. The one thing that could be interesting to do together is actually getting the OS update mechanism going. I might be kind of optimistic because it's not the most trivial logic to put, but effectively being able to recreate that VM on the older image and then making it so that the tool on first startup checks what the OS version is and then triggers an update and reboot if it's not on the current version, and then on reboot can run the tool again. It should be saying, hey, yeah, you're up to date, and then actually proceeding to installing the layers. So we can probably try and do that during this live stream, see how far we actually get with that. The logic is already in a shell script, so it's not new, but needs to be converted and like properly talk to GitHub and all that kind of stuff. So let's see if we can't do that. I'm gonna delete the VM then and actually do spawn again so that we get, oops, so that we get an updated image up and running. And then to do that, there's going to be a few things needed. The first one is we need to add a, you can actually put that, just opening a notes file on the side, hold on, there we go. So the first thing we're going to need to do is actually add logic to find what the current version is of the image. That's pretty easy. We can parse that same OS release file I was showing earlier. That's probably the easiest way to get that version out. So we need to add that. Then need to, if this is different from the current release on GitHub, then we need to go and download the artifacts for that. And once we've downloaded the artifacts for that and put them in place, then we need to actually trigger the sys update from systemd. Again, shouldn't be too bad, but we can try and get that done. So just going back to Incus OSD, building it, we're all up to date, it's fine. Pushing that. There's actually one thing I noticed which is wrong. There's a bunch of things here talking about OS extensions when it's actually system extensions. So let's just fix our wording a bit. Downloading system extension. I think that's the only place that was wrong. Okay. All right, so if I run it now, it's just gonna go and download those two files and apply it. The other thing that's maybe worth mentioning is that the current implementation, it doesn't know how to check whether a given system extension is up to date or not. It's actually not trivial to figure out whether it is, because the systemd sysext command doesn't actually tell you the version of a given extension. And yeah, so it's slightly problematic. I actually meant to try something, but I don't know if that was actually just like a random trial type thing. So if I do debug.foo.ra and incus foo.ra, what does it see? Yeah, the names is derived from the file name. So that would be a problem. We can't do that. The name needs to actually be incus and debug for things to work. Okay, that would have been too easy. Anyway, like we effectively have no way to know whether it's up to date or not. And because of that, it means that every time you run the command, it just goes and updates it because it doesn't know any better. That's fine. Down the line, my current plan is to actually have a state file that's stored on the encrypted storage, so it's safe, which tells us what was the last OS update we tried to do, what's the latest version of the different layers that we have applied. And so based on that, we will then only go and download something if it's a different version than what we're currently running, avoiding that problem. But until now, the command effectively always assumes that I'm updated and goes and downloads the new thing. So anyway, this is working fine. So now the next step is actually we need to parse this. I keep doing etc because it's normal location, but given we're immutable, it's actually in lib OS release. So we just need to parse that and locate this field. So that shouldn't be too bad. Yeah, we can just do a buff.io type stuff to read it. All right. So we'll put that in the systemd package, I think. And probably under sys update, which we don't currently have. So package systemd, and then func is get current release. And we'll want that. I mean, so far everything I've always passed the Go context now, try and do a bit more of a modern Go design. So even if there's nothing to really cancel at this stage, I'll just always pass a context because at some point there might be. And we're just going to return a string or error. Okay. And then we're going to need buff.io probably to try and parse this thing nicely line by line, and OS. Okay, and OS open of lib OS release. So just opening the file read-only here. Oops. Then making sure we close the OSD. So it's buff.io.new scanner and then the FD, I think, that we want. And by default, it's scanned line by line, I think. I'm actually just trying to remember. I use it already somewhere, so I just want to make sure. Okay, it's FD scan, I called it. Just trying to be consistent on variable naming. Okay. And the for loop for FD scan. I don't think we actually need to do anything too special with that. Yeah, for FD scan.scan. Okay, cool. All right. So now a line of that is effectively FD scan.text, I think. And that's gonna be each line. All right. So then we just want to split on the first equals and then treat the rest as the value. That should be fine. So fields, we just want to do a string split n of line split on equals, and we want, I think split n is the number of splits, not the number of fields. Is that right? You just go check the doc real quick. Yeah. I remember it not being the most intuitive, so let's see. Split n, the n is the count determines the number of substrings to return. Okay, so it's actually number of substrings, so it should be 2. All right, cool. So given that, now we know, I mean, first, if len of fields is not 2, we're just gonna skip it as a bad line so we don't risk crashing. And the current release then is effectively if fields. I'm just debating internally whether to do proper parsing of this stuff, so like getting rid of the quotation marks and all that stuff and filling a map and then returning the one field, or just dealing with the one field we actually need, which is basically what we need here. I think I'll just go the easier route. Like it would have been easy to put a full OS parser, but I don't think we actually need it since we don't need the other fields. It's really just the image version we care about. So we can easily enough do that. So if field 0 is image version, then we're gonna be returning strings dot. Is there one to trim on both ends? Because I want to do a trim prefix and suffix. I don't remember if there is a one that does both ends, or if I need to call them both. Let's see. Trim spaces, trim right, trim prefix, trim left, trim func, trim. So there's a generate trim, which returns a slice of the string as with all leading and trailing Unicode code points containing cut set removed. Okay, so that should actually work. So we want to trim the actual string, so that's fields 1, and we just want to remove the double quote from both sides. Okay, and then we return. So that should do it. And then if we ever reach that path, then it means we have failed at finding the version. So okay. Now it's gonna complain because of missing imports. Sure enough. So format is missing, string is missing. Okay. Also missing a doc string, but that's a bit of an issue. Currently, I've not implemented that anywhere else. Returns the current image version from the OS release. All right. Let's hook that up now and see if that works. So when we say, so the message that says starting up here, we can probably retrieve that version, that info before it, and just do release and pass the release here. Okay. Okay, so it's release error systemd.get current release, and that. All right. Now it's complaining all over the place. That's not too surprising. I forgot to pass the context. So let's fix that. Context goes in. Then next up, 75. Oh, right. Okay. Already, like that code needs to actually go into its own package, just hasn't yet. And yeah, it's kind of stepping all over on that existing variable name. So let me just fix that real quick. All right, so that should avoid that conflict, and then push the binary, and let's run it. So, starting up, release equals, and we've got the correct release. And right underneath, it detected the current release on GitHub as being more recent, so that's cool. We've got that working correctly. Now, what we can do, it's going to be on the kind of GitHub side of things. Currently, the logic here, and again, that needs to move it into its own package. It's a bit of a mess right now. We pull the current, the latest release from GitHub, and then list all of the release assets and prepare the update. So here we're effectively skipping any file that's not a system extension, which is fine. What we should probably do is actually make this a specific loop for download system extensions. And we're gonna want something similar for actually download OS updates. So it's going to be very, very similar. Actually, most of the logic will be the same, and just the paths are going to be slightly different. But that should be fine. So if we go here, and in this case, the difference is that we will only do it if the version is different, since we can actually check that. So if release is not equals to GitHub release.getName, I think is the magic there. Then we go and apply an update. I think, so downloading OS update. I'm gonna need to change the condition a tiny bit. We don't want to trigger quite on the same files, obviously. And the problem well, not really a problem, but if we go back to GitHub, those files are somewhat unpredictable as far as their file names. So we just need to look by prefix effectively. So we need to download anything that's Incus OS _, but exclude this one. So we need EFI, but we don't need the ra.jz, except for those user things. So I just need to kind of do a bit of a filtering logic there. It's not too bad. But yeah, we just need to deal with that. All right. So also the destination is going to be different. So currently we download the files and we also decompress them and then write them directly to a matching path under system extensions path. So this is going to be under sys update path, which is, I'm actually trying to remember what that is. If we go in Incus OS and look at the script that applies the update, it pushes the updates and the value updates. So that's what that path should be. So let's go up here. Those should also move as constant into the systemd package instead of being here, but a problem for later. And here we go. So downloading OS update, sys extensions. So that's part needs to go away. And we're writing that into sys updates path and decompress. So that's good. Now I just need to add some logic for the files we actually do want to transfer. So let's see what's gonna be the easiest. I could do like a regex type stuff, but that's not super fun. I think easiest is probably to split on the dot and then check what's after that. So that will get us EFI.jz, raw.jz, or user.blah something. That's probably gonna be easiest. So if it doesn't start with Incus OS, we skip, then we split on the dot, and then we skip if it's just raw.jz and not the rest. That's probably easiest. So if assets.get name, not strings.has prefix displaying Incus OS underscore, right? Yeah. Okay, so we want to skip all of those because we only care about the OS update. Skip system extensions. Okay, we're just skipping those. And then for the OS update, we'll do fields and strings split on asset get name. Actually, we can do a split n again. It's 2 pieces out of that again. We skip invalid entries again. And then we skip the full image, which should be fields. Second field is raw.jz. Okay. So that should skip that. Now let's see. All right, I forgot an argument here. I just forgot to tell it what to split with. So there we go. Oops. It's not equals, it's dot we want. Forgot. We'll split in here. Okay, so splitting on dot instead of equals, building not, and let's push the binary. So, right. Now it crashed. Cool. All right, so let's go see what's going on. Line 107. If fields, all right, that's not 2, it's 1. Whoops, sorry. And push. Okay, let's try it again. Okay, so getting trusted system keys, downloading image, and in effect, what happens, the folder doesn't exist, which is fine. I was actually wondering if that was going to happen because we've got the logic here for the system extensions path to create it, but we don't for OS updates, so I should just do that too. So that's this updates. This updates path goes here, and comment here is incorrect, so let's just fix that too. Push and try again. So this time it's working. So it's downloading EFI user, because it's just 4 files we're supposed to download. So long as it doesn't download anything else, we're good. Now it's downloading the system extension, that's fine. So the OS download part worked. Now the question is whether the files landed correctly, that systemd sys update can see them. So that's gonna be the next question. We need to do some pretty weird stuff to actually access, to actually run this update currently. So I'm just gonna go and try it by hand to just see if it works. So we'll do that unit start here. Whoops, I'm running from inside the VM. I don't need this Incus stuff. There we go. And then in the namespace, so there's a whole bunch of unshared stuff going on. That would kick in the entire update. We obviously don't want that. So I just want to look at its state. So just do sysupdate with nothing else. Yeah, okay, cool. It sees it as a candidate. So that worked. The files were downloaded correctly. Now the trick is going to be to actually run effectively that command to apply it. Or those two commands more specifically. So running sysupdate with the update argument and then running reboot to restart the system. All right, that's not looking too bad. I was wondering why, because like there's that workaround of starting the boot unit. I think I can do that also from within the new function to apply the update, effectively just isolating all of that. So, and let me check actually the update commands. Does it take any arguments or anything? Can we tell it what to run exactly? Yeah, update, and it can take a version. Okay, cool. All right, so we can do that. Let's go and write some more code. So in internal systemd sysupdate, we'll do a new one. Let's call it apply update. Pass in the version, and it just returns an error. Okay. Context to ctx. Okay. Right. So the first thing it needs to do is start that mount unit. We'll just put that as workaround. Start the mount. What was the name exactly? Boot.mount. Okay. Unit. So /boot AutoFS is active before we create a new mount namespace. Okay, so that's good. We're just going to be within the same package, and is there a start unit? There's an enable thing, but I don't think we've got a start unit yet. So we need to do start unit of boots.mount, and that should be fine. Well, context needs to be passed through. If that fails and the whole thing fails, fine. Okay, needs to actually go in this one and create a start unit function as well, because we don't have one of those yet. Gonna be pretty similar to this guy. So the main argument is start, and then we append the unit name start past as an argument, and then we shove that to systemd systemctl. Systemctl start units. Yeah, that should be fine. Okay. Does that build? It builds. Good. All right, so back to sysupdate. Now we've got that unit started. The next step is to actually run through the update. The ugly way to do it, and I think it's probably the way I'm going to implement it for now, is where's the unchain? Is to basically run it this way, like through a shell, and call the mount call we need, and then sysupdate with the right version, and then a call against sysupdate with reboot. We should actually make rebooting probably an argument here. Okay. It's just gonna be kind of annoying because we need to prepare like a string of what we need to do. Workaround needed. Actually, let me check something, because this stuff is a workaround for a systemd issue. Maybe the systemd issue was resolved. I should probably have looked at that earlier, but nope, it's not resolved. We still need a namespace. No. It's just systemd is confused when system extensions are applied on the system and you're trying to run a sysupdate. And because we want to use both, we need to use that trick to kind of hide the system extensions temporarily while the update is run. Anyway, until systemd sysupdate can be run with system extensions applied. Okay, so we need to actually put together the command here. So the command itself at minimum is going to be mount dev mapper user on top of /user, and then we need the version string in there, and then call systemd sysupdate update with the version. So that's the minimum we need to do. And then if reboot is provided, then we go and expand that a bit with, I think that should work fine. So, and same command, reboot. All right, and then we need to actually run the command. So subprocess run command context. Actually, yeah, no, that's fine. It's the one we want. And then this one should run unshare -m, and then as a single argument, not as a single argument, we want -- separator, and then shell command string, and then pass in the whole thing here. That should be okay. Then bit of error handling and return. Okay, let's see. Subprocess is unknown. Yeah, just need to add it. Okay, here we go. So then we need to actually do the plugging of that thing, and we're gonna call it with reboot. So what's gonna happen is effectively, as soon as we reach this point here and the updates are put in place, we're gonna be calling systemd apply update, I think. What was the name? Yeah, apply update. I think I probably want apply system update just to be clearer. Okay, apply system update. And here we want the release name after the context. And we do want to reboot. So if things fail, we'll return the failure. If things succeed, we don't want to try to go any further because the system is imminently going to be rebooting, so we should just exit. Okay, 140 is unhappy. Wrong file. Oh, right, it's GitHub release that we want, because release is the current OS version. Okay, let's push that. And now, if all goes well, it's gonna go and download that release. Okay, put it in place, and then it will immediately go through with applying it. Yep, and we're rebooting. Okay, So when the VM comes back online and we rerun the command, this time it should see that we're on the same version, so those two should be the same, at which point it should go straight into sysext instead. Let's see. Yep, exactly doing that. Cool. So that's effectively our kind of first boot auto update mechanism sorted. Like if we do go and delete that VM and we spawn it again, oops, spawn. Okay. So if we create a new updated VM and then we transfer the binary to it, we should see actually what's expected on first boot, which is initially you don't have Incus, you run the update, you run the binary, it sees an update, updates the OS, reboots, runs the binary again, this time no update to apply, goes on and downloads Incus itself, and then you've got Incus up and running. So that's how that should be working. Obviously this should be a daemon, so you don't need to transfer the binary and run it by hand. It should happen automatically. So on first boot, as soon as it's got network connectivity, it goes and checks if it's updated. If it's not, fetches the latest one, reboots, and then downloads the system extensions, applies them, and then goes on to do Incus provisioning. So that's gonna mean make sure it's on the network, load initial keys so that you can connect to it remotely, which is going to be pretty critical because like right now I've got a shell I can interact with. The only reason why I've got that shell is because it's running inside of an Incus VM and we've got the Incus agent loaded in there for development. When it goes onto an actual system, you won't have any way to get a shell into this. So that needs to run on its own automatically on first boot to the point where you actually have the Incus OS daemon running and Incus running, and you've got a trusted key that you can then use to interact with that through the network. All right, let's go in there. So pushing out updated binary, and not in the right folder again, there. And now if I run that binary, okay, it validated the key, sees it's in release mode, sees it's outdated, downloads the update, and it should reboot. Yep. And at that stage, we'll be able to check, but there still won't be any actual Incus command or anything deployed on that system. It's literally just updating the base image first. Still booting up. There we go. So if we run Incus without a typo, it's not there. Now if we run the binary again, it says it's up to date, goes on to system extension download, and then applies them, starting Incus, admin init auto. And sure enough, we've got Incus up and running. Okay, I'll probably gonna leave it at that because anything else on the to-do list is gonna take quite a bit longer than can realistically fit in whatever time I've got left in this stream. But yeah, that's looking pretty good. The next step I think for me is gonna be a bit of refactoring around the GitHub release handling stuff. That logic needs to go away from that main function into its own package. Effectively, the idea is to build multiple different sources for that data. Right now, this is an image that's built on GitHub, downloaded through GitHub, and the right way to update it and download the extensions are all through GitHub. That's fine. But if you're running in a development environment, we won't be able to download the system extensions from GitHub. So in the development environment, it needs to instead skip a bunch of those steps or just look at whether you've already uploaded them into place. And if you have, then use those. Another source that will be supported is going to be the Operation Center. So in the future Fusion Cloud type deployments with our suite of components we're building, the Operation Center acts as the hub to download your updates and system extensions because it's designed to run in an air-gapped production environment where you can't just go and talk to GitHub. In those environments, you also want those images to be tested and slowly roll out and all that kind of stuff. So instead of talking to the GitHub API, we'll be talking to the Operation Center API in that use case. So it makes sense to kind of abstract that, effectively having a package for update sources and then implementations for GitHub, local development, and Operation Center. And each of those needs to offer the ability to check what the current latest release is, download the OS image, download an OS update, download system extensions, list system extensions. Like I need to write a Go interface with the functions we expect, and then put that in place. And then based on the mode, we'll pick one source or another to go and reach and download those files. The other step that's needed, obviously this thing still needs to turn into a daemon and have an API, but even before that, what it needs to do is actually provisioning. So look for an initial config. I'm currently thinking of just having it be a file on the EFI system partition. So having like a bootstrap.yaml file on there. And so on boot would see that, and that would tell us, hey, this is either Incus or Migration Manager or Operation Center as the application, but also that's how to connect to the network. Also, okay, you're currently running from a USB stick, but actually want this on the main drive so that it knows to copy itself on the main drive and then reboot. There's like a bunch more things we need to have the user be able to provide. And I need to find the best way to do that. One idea, as I said, like, is to put it inside of the EFI partition. The problem is that it's not trivial to inject that file for a user generating its image, like the first image for that. We need like another idea would be to effectively do kind of what systemd does, where they use partitions when they actually need extra data. So we could put like a tiny partition at the beginning of the drive, which is only used to hold that initial provisioning data. And you just literally write the YAML data to that partition, and then we read it back. That could be an idea. We'll say, like, I need to find the best way to handle that. The main plan really is to have a tool, potentially even the website or something, where you can enter your initial config that you want, and you get effectively a custom disk image that you download that already has this thing pre-baked in that you can just write to your drive, boot, and you're done. It's also not impossible that we support multiple ways to do that initial provisioning, that we effectively support either reading a file from the EFI partition, or looking for the special partition, or looking for another USB stick with a special partition ID or something. Just trying to make this, like, this initial customization kind of easier, so that it's possible to just put that in place. The other thing we could do, I don't know if I want to do it, but the other thing we could do is have the daemon actually interactively ask questions on first boot. So if you don't have any of those files in place to actually seed that initial configuration, then it would go and actually ask you, being like, hey, you've not provided me with provisioning data. Do you want me to copy this on the main drive? What's the network? Is there anything special to do for the network? What kind of initial Incus key should you load? That's going to be a fun one, because providing a full key interactively through a prompt is not going to be fun. But yeah, effectively trying to just put those things into place. All right. Jared is asking about the cat. I don't actually know where the cat is, so let me go see if I can find the cat within 30 seconds. If I can't, then that's going to be for another stream, but I'll go see. All right. Look what I found. He was having quite a big nap. on his cat tower in the other room. So anyway, my first guess as to where he was right. Bit of a sleepy head. Anyway, that's for the cat segment of this live stream. Is trying to claw me a bit. All right. Yeah, he's quite a big boy. All right. And he gets to go back to sleep now. All right, I think that's it for this live stream. I'm gonna be committing some of that code in the next few hours on GitHub. We're still pretty far from this being able to just run on whoever's machine, but I think we're getting pretty close to being able to try it outside of an Incus VM. So that's pretty exciting. As I was saying to someone else yesterday, it's really nice to see kind of all of the pieces falling into place slowly. And we're definitely feeling that quite a bit here, where, hey, the whole immutable thing is working, updates are working, applications can be deployed on there, we can have Incus running. It's just a bit of missing glue here and there to make this whole thing work seamlessly, but we're not really far away from that. And we can definitely see kind of, well, what we're going to end up with, which should be really quite exciting. And as soon as we can have some people starting to play with that on some test machines in their home lab or the like, I'm sure we're going to get a bunch of very useful feedback for the missing pieces and the different things we didn't think of, and can then get relevant GitHub issues and go and fix those. So very exciting times. Looking forward to keeping on that work over the next few weeks. And thanks everyone for watching. All right, have a good one, everyone. Bye.